Have you ever wondered what would happen to our planet Earth if our beautiful sun that you see in the background has undergone a nova and changed into a white dwarf? Well, today we're going to do that in Universe Sandbox 2 and find out what happens. Welcome to What the Math. And so for this video, we're going to be using this climate simulation, which allows us to see planet Earth without really any clouds, without any atmosphere, so that we can actually see what's happening on the surface. Now, this is Earth at its prime. Basically, this is, what's happening right now. We have winter in some parts of the world, we have summer in some other parts of the world, and essentially, if you were to run this really, really fast, you would see that the climate changes with seasons, obviously. So here's winter in the northern hemisphere, and now it's summer in the northern hemisphere. And the opposite is happening on the other side of the planet. In the southern hemisphere, we have Antarctic ice shelf receding or increasing in size. Now, all right, so let's see what happens if we suddenly experience a nova. And obviously, this is something that we don't expect to happen for the next 5 or 6 billion years. But you never know. Maybe it was miscalculated, maybe something is not going well for our sun, and it suddenly becomes really, really, really old and starts getting older and older, the temperature starts increasing, and at some point undergoes a nova. Boom. Alright, sun nova remnant. When this happens, what will happen to our sun is actually it's going to turn into what's called a white dwarf. Now, white dwarfs are really interesting because they're very, very small, first of all. They're only about the size of our planet Earth, but inside of them, you get this really highly dense carbon-oxygen material that is essentially, at first, is very, 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 very hot. Right now, this star is about 60,000 degrees Kelvin, which is essentially close to being 60,000 degrees Celsius. Now, we're going to go back to Earth now, and we're going to change its orbit back to where it was before, because since the sun is now a lot less massive, the orbit of our planet Earth has changed dramatically, and we're going to play around with this later, but let's just for now change it back to what it was. 1 astronomical unit and almost no eccentricity. So here's Earth orbiting as it was before, and let's find out what happens to our planet Earth if the sun, changes into a white dwarf. Now, if you were to stand on the surface of the planet, and if you were to try to look into the sun, you would see a very interesting, kind of bright but very tiny blue/white spot in the sky, and this is basically what's left of our sun. It would be a very piercing light that would be very difficult to look at, obviously, because it's so hot and so bright, but at the same time, because it's so tiny, its total luminosity would be very, very low. And the thing is, when the white dwarf is just formed, and in this case it's the sun right there, it is actually super hot and very, very bright. So it's about 5 times more bright than the sun was in the beginning, meaning that our planet right now is going to be receiving a huge amount of light. If I were to accelerate time a little bit, if you were to look at this temperature right here, you would see that it's actually increasing dramatically. There's no more ice sheets left in the north, and the southern ice sheets will also disappear very, very, very quickly. Essentially, everything here will now start heating up and become ridiculously hot. So you can kind of see the oceans are actually already receding, and a lot of the water on the surface is already being evaporated. The greens and all of the vegetation has kind of started to disappear. And our planet is now at a temperature of 120 degrees Celsius. This is only a few months after the nova, after the sun has become a white dwarf. All of the oceans have now almost completely disappeared. We now have a barren Earth, ridiculously hot, very, very unfriendly, and possibly devoid of life. Now, this temperature is currently very similar to the temperature of Mercury, and possibly even hotter than Mercury. And within a year, we'll reach temperatures of possibly closer to Venus. And this is, of course, going to destroy almost everything on the planet. Only some of the most extreme forms of life, also known as extremophiles, might be able to survive these really, really hot temperatures. But our planet, for the most part, will become barren of life and will reach total temperature of, I think the maximum temperature was, I kind of missed it, but it was approximately 350 degrees Celsius, just below the temperature of Venus. Now, this, of course, will not last for a very long time, because white dwarfs are interesting in that they start super hot, and then they get cooler and cooler and cooler with time. And over time, the luminosity and the heat will start dropping, and our planet will start receiving even less sunlight. And I can actually show you this in more detail by changing this to, let's say, millions of years. Or actually, let's start with 1,000 years. So after 1,000 years, the temperature will have already decreased. There's a lot less light that's being produced. And every few years, this will decrease even further. You can kind of see it slowly decreasing both surface temperature and luminosity of the white dwarf. Now, it will take several million years for this to actually cool down to the point where our Earth can become habitable again, and we're going to simulate this in a second by doing the following. I'm going to go into millions of years here, change this to 1 million years, and start increasing the age of the white dwarf. And let's see after how many millions of years our planet will become habitable again. And so within 6 millions of years, you kind of see there's already liquid water again. Our planet is kind of habitable. The temperature is decreasing. It'll probably drop closer to 0 degrees now. And all of the oceans that were on our planet, including the ice peaks, are slowly returning back here. So this is within several millions of years after the white dwarf formation. And the temperature will now actually start dropping even lower. As a matter of fact, after that point, every single year will start losing temperature. And within a few million years, this is what our planet will transform into. It's going to slowly become a nice world. It's going to become what's called a snowball Earth. You can kind of see the ice sheets forming starting in the north, and there's probably some coming from the south as well. And this will actually happen as soon as our sun has lived its main sequence life and become a white dwarf. And then as soon as the white dwarf starts cooling down, this is essentially what's going to happen. Now this is within about 5 to 6 million years after the white dwarf formation, and it will never return to being warm or habitable ever again. So the only possibility for life now would be underneath this ice sheet, in the parts of liquid water that is still underneath, which will actually eventually freeze over as well. But for now, this is essentially it. So this would be the end of life on our planet Earth, and this would happen within about 5 to 6 billion years from now, and then about 6 million years after the white dwarf has been formed. Now, as I keep advancing time here, the temperature will decrease even further, and at some point, billions of years into the future, which unfortunately we can't really simulate this very well in the game, but what will happen to this interesting white dwarf is that it's going to eventually cool down to the point where it becomes known as the black dwarf. Now, black dwarfs are very theoretical because even though we have white dwarfs out there, it just takes very, 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 very long for black dwarfs to form, and we don't really know. At least we think that they don't actually yet exist yet in our universe. Because of the amount of time it takes to form one, we don't really know how long exactly it takes, but yeah, we definitely haven't seen them. We'll definitely not see them for a very long time, and they probably still don't exist. They're very, very theoretical, but they kind of look like this. I'm going to show you one that's already pre-made in the game. So here's actually a black dwarf in the simulation called Supernova. I think it's actually right here. It's called Supernova Close-Up in Real Time. So this is an example of what a black dwarf would look like. It would be basically a very, very, very dark star that emits almost no light and is essentially as dark as they come. And inside of this star, you would basically find a lot of carbon, oxygen, and possibly some other heavier elements that basically get stuck there forever. Now, the thing is, for this simulation, we've actually changed the orbit of Earth to make it more circular. But in reality, when the sun does undergo nova, when it actually becomes a white dwarf, it's going to lose a lot of its mass, meaning that our planet Earth is going to get kicked out into the outer solar system. And let's see what happens with our climate in that case. So we're going to go back here again and change this to 11 billion years. Boom, it's going to go nova and change into a white dwarf. And as soon as this happens, our Earth will now have acquired a much stranger and eccentric orbit. So as a matter of fact, if I were to go out here and show you the orbit, this is what it's like now. It's this really, really long ellipse that goes all the way to where Jupiter used to be, and then it's going to come back here again. And all of these planets, all of the planets in our solar system will actually acquire a very strange orbit. So there's going to be a lot of reshuffling. Some planets might actually get kicked out completely out of our solar system. Some planets might re-establish orbits closer to the star. But in case of Earth, it's at first at least going to travel farther away. And let's check out how the temperature will be affected by this. So because our orbit will not be so eccentric, it's very likely that we'll have very strange seasons. One of the seasons will actually be very tolerable when we're on the outskirts at the apoapsis of our orbit. Farthest point of our orbit will be very far away from the sun, and at this point it's actually going to be relatively nice here. You know, the temperature here is going to be what, about 20 degrees, maybe a little bit lower. Let's find out how cold it is going to get. But yeah, so at this point right here, this is when you can kind of survive on our planet. Oh, it might even get colder. Look at that. It's getting to the point of below zero. We might actually change into a snowball here. But then, as you can guess, we're going to approach really close to the sun, and that's when things will not get so comfortable anymore. Things, as a matter of fact, will get very uncomfortable. There will be a lot of really hot temperatures. So right now, with like minus 60 degrees Celsius, this is essentially temperature you find in Antarctica, except the entire Earth is going to be like that. And that's because we're so far away from our sun right now, from the sun remains, I guess. And look at that, it's minus 100 degrees. That is actually a lot less than I expected. But now, as soon as we pass that point of apoapsis, of the farthest point in our orbit, we're going to start approaching this our sun. And as soon as that happens, the temperature will start going up again. And so surviving on this planet might be actually very difficult, because the temperature differences will be so high. Very high, as a matter of fact. And let's see how much it's going to warm up in this time that it spends close to the sun. And I think because we spend so little time in our periapsis, or the closest part of our orbit, we might not even have enough time to warm up and to melt all of this ice. So it's possible that after the sun goes nova and becomes a white dwarf, even though it is super hot, there might not be enough time for us to actually melt the water, so the planet might actually stay as a snowball after all. So as soon as sun becomes a white dwarf, it is very likely that the planet Earth will actually become a snowball for good. Now let's see if this is going to be what I expected to happen. So we're about to reach the periapsis, I think. Actually, no, we've already passed the periapsis. We've definitely passed the periapsis, but it looks like our orbit has changed a little bit as well. So the thing is, the planetary orbits will start to re-establish circularity with time, but it will take many millions of years of orbiting the sun for this to actually happen. So right now, I'm not exactly sure what's happening on Earth, but it looks like it's still frozen. So let's actually run this for a few thousands of years and find out what happens to our beautiful planet sometime in the future, within thousands of years of the formation of the white dwarf, the sun. And I've actually changed the graph here a little bit so you can kind of see the progression with time, and looks like the planet is slowly warming up. It's actually kind of going up. The temperature is now closer to like minus 15 degrees Celsius on average, and I think within about hundreds of years, and by the way, 1 year now takes a few years. I think it actually takes 22 years. 1 year on Earth is now 22 years long, and so it's a little bit obviously a little bit colder here, but it's also, our summers are obviously going to be a little bit longer as well. And so it looks like with time, mostly because of the changes in orbit and because we're still trying to restabilize the orbits, it looks like our planet Earth might actually get a little bit warmer after all. And it looks like we've established a repeating pattern here. So our winter on the new Earth is about minus 50 degrees Celsius, and our summer on planet Earth is about minus 6 degrees Celsius. It's still a snowball, as you can see. It's covered in ice, but there is a little uncertainty with our orbit. We're actually crossing the orbit of Jupiter, and it's very likely that at some point, if we cross to Jupiter, or if we approach Jupiter close enough, we might get a new orbit entirely. And it might happen right now. Yeah, look at that. Jupiter has now kicked us out of the old orbit, And we've changed the orbit yet again. And this might actually happen a few times. As different planets approach to our newly created Earth, we might experience a lot of seasonal changes again. So just to summarize, what will happen to our solar system when our sun becomes a white dwarf? Well, first of all, obviously the Earth will freeze over. And second of all of the planets will actually acquire new and very unpredictable orbits. A lot of them will become very eccentric. Some of them will be once again affected by Jupiter, and it's very likely that it's Jupiter and Saturn that will actually help other planets reestablish newly formed orbits, and will either kick them out of our solar system entirely, or will possibly cause all of the planets here to acquire a new circular orbit around the sun, but in a completely different area. So it's very likely that Earth might actually then get kicked out to the outskirts and have a new orbit somewhere else in the solar system. And just before we finish this video, let's actually take a visit to other planets in our solar system and find out how they're doing as well. So Mars is obviously also very, very cold. It has a very, very eccentric orbit, and it's very likely that it is going to get kicked out of the solar system at some point as well. Then we have Mercury, which is very, very close to our sun, and it's still there. It's just in a slightly different orbit. Its temperature has increased to about 220 degrees Celsius, and it basically is higher than it used to be. And lastly, we have Venus here, and it seems to have a really interesting pattern. So right now, at the apoapsis, is the farthest point of its orbit, its temperature is about 100 degrees Celsius, so it's a little bit more manageable. But then Venus approaches the sun, and at its closest to the sun, its temperature increases to, 700 degrees Celsius, where it actually heats up and even lights up. Other planets like Saturn and Jupiter and Neptune and Uranus are still obviously gas giants, and they're not particularly interesting because we won't be able to settle on them anyway. But it looks like everything in the solar system has actually become either very eccentric or has completely left the solar system and has gone somewhere else in the universe. Well, I think that's all I wanted to talk about in this video, and hopefully you learned something from it, and hopefully now you know what will happen to our solar system and to our planet Earth when one day our sun undergoes a nova and becomes a white dwarf. Thank you so much for watching, and if you've enjoyed this video, don't forget to share it, don't forget to like it, and possibly even leave a comment below letting me know what you think about the future of our planet Earth and our solar system. If you still haven't subscribed, don't forget to subscribe, and if you would like to help this channel grow, don't forget there's a Patreon page that helps me a lot with purchasing new equipment to make better high quality videos in the future. Anyway, thank you so much for watching, guys. I really appreciate all of your support and all of your awesome comments. I'll see you in the next video, game you later, and as always, bye bye.